Wires, wires everywhere. Whoa. Right, here we are. This is the next day after I made the introduction video of this MurphyU102A. I took it outside after I filmed that and gave it a good scrub down with warm soapy water, trying to avoid all the coils. I then cleaned the coils, which are down here, with a very fine artist paintbrush just to get all the dust off. And then I used electronic cleaner, just isopropyl alcohol to clean them. And it came out not too bad actually. It certainly made it nicer to handle. So what I've done now is I've pulled the rectifier, which sits up there, and I've pulled the output tube, which sits there. Notice audio output transformer there. And I'm going to try and reform one or more of the capacitors a bit just to see how they go. Give them a little bit of a tickle before I apply mains power. So the audio output tube is here. It's a biggie, and you notice it's got a spray metallic coating on it, and these tend to peel off, especially around the base here. Unfortunately, this valve is positioned right above the audio output transformer, as you just saw, and bits of this conductive coating were falling off or laying on the output transformer. So it has the opportunity to short the terminals. So what I've done is I've got some French polish in a little bottle and painted it on, and it's stuck down quite nicely now. I might put some PVA or something around it just to hold it back together even better. There's the rectifier tube valve, sorry, God, I said tube, valve. And again, quite unusually, this has a full coating of the metallic spray on it. Unusual, but quite usual for Mazda. There's another valve for the normal transformer sets called a UU6, very similar to this, and that has it as well. As you can see, it's not in the best of health, so I'll do the same with this. The French polish or shellac will slide underneath the gaps here. Oh, get it in focus. Will slide underneath the gaps and help to stick it down. Not much I can do here if it does fall off, although with the rectifier being up there, if it does fall off, it's not really going to land on anything crucial. But the audio output transformer, obviously if bits fall off the output tube, they're going to fall on those 5 or 6 terminals there, and in fact it already was. I've tested the output transformer, it is fine. So what we're going to do now, I've got my Keithley meter hooked up. We're going to try and reform as best we can this capacitor. Now this is really dangerous. There's a lot of voltage here. I've got it on the lower setting at the moment. There's 240 volts, albeit at low current. Don't start moving your hands around and stuff. Right, so you've got 240 volts coming out of here, and what I'm doing is I'm monitoring the output at each end of a 100R resistor. So when I switch that on, I'll show you a bit more. So let's switch the reformer on. So that's actually measuring voltage, so I've got to times that by 10 to get my milliamps. And I have had this on for about 10 minutes, a little while ago, and it was down into the 1200s, 1290s I think, but you can see I've got about 13 milliamps going in there, and that's not great. It should be, I think that's an 8 UF capacitor, you know, it should be a lot lower than that. Should be under a milliamp really. So there we go. So I'm going to sit here and watch that meter go down over 15 minutes, see if I can get it down, and then we'll this one's actually a double can. There's a 16 and an 8 in that one, I believe, and this one's just a single 16. That's huge, isn't it? Pretty sure I've got that the right way around. So yeah, all's going well so far. Right, a little bit later on, and I'm actually trying to reform this big cap here. So the lead's going over the front there. Excuse me. And it started off about 2.8 volts, or 228 milliamps. Sorry, now it's down to about 15 milliamps. And if you, I'm not reforming this one that the crock clip's connected to, but it's in circuit, and as, if you like, as the reforming process goes onwards, the voltage on that cap increases. So when I first tried to reform it, it was down about 123 volts. Sorry, let's get the light off you. It's now up to 129. And that other cap, the other side there, would be about 157. See if I can do it without zapping myself. So the last time I looked, this side was 157. Let's have a look now. Nah, 159. Oh, sorry, 160. So they are reforming a little bit. I doubt they're any good, and I suggest that I'll end up just restuffing these anyway, because, you know, even if you reform them, they could short out any time, and that means just taking the whole radio apart, so you might as well do it right the first time. It's a shame to restuff things like this, because once you do, they're sort of gone forever, but I'll try and do it so nothing's seen. But I just thought it was a bit of fun trying to reform them. I sat there about 15 minutes now, and it's slowly coming down, but not really. And it's quite funny, well, not funny, it'll go up to say 148, and there you go, 1489, then it'll dive back up to 1495, and then it'll come all the way down to 1480. This one's actually going up a bit now. That suggests it's getting hot. There you go. Yeah, it's going upwards. That suggests that it's done. That's knackered. So that suggests it's getting a little bit warm. I'm gonna wait for it to discharge. Right, that's discharged, and it's not really getting warm as such. Well, maybe it is. So unfortunately this one looks like it could be a little bit knackered. I'll give it 10 minutes and try again, do it slowly, but you know, 1947 this was made. I would think that's the original capacitor. It's probably just shot by now. But anyway, a little experiment that is probably going to end up a pointless experiment. There's another thing that I'm going to document while I've got the radio to bits. I've just noticed that the pointer string here was starting to get a bit frayed, and noticed it was catching on the inside of the dial glass here, and I thought it was just these rubber bits had moved and they've gone rock hard. They're just like a rubber channel to hold to cup the dial glass, and they've gone hard, and I just thought it had moved back a bit. But on further investigation, what I found is this whole dial pointer tuning gang mechanism, this whole wheel is actually connected up wrongly. I'm guessing someone's, or at some stage, the dial string has broke. If you look, you see that? It doesn't, it sometimes doesn't seat properly. It doesn't seat properly. And this spring here shouldn't be there. That should be one continuous bit of cord. This spring should be connected in there, in that hole there. And now, if you can see, can you see the light shining through this hole? Well, the tuning gang, this thing is driven by this rearmost bit of cord here, and that should sit, that should go around the wheel, and then there's a little gap just there, and the cord comes down the back and then through this slot here and then onto the spring, and it obviously isn't, so it isn't working properly. And I thought it was tight. When the pointer gets right up the top, which you won't hardly see, just see it moving just there, it can't go any further because that spring on that bit of wire is now hitting this shaft, so it won't turn anymore. So someone's bodged that in at one time, or tried to make a quick repair without the restringing diagram. But as you turn it, see if I can make it do it, sometimes it pops completely out. It might do it any minute now. Nope. Sometimes it pops off the top here as well. That yeah, that springlet, see, you can't get right down to the bottom because that spring started riding on the drum there. And what I've got is I've got a bit of paper to stuff up behind here to stop that bit rubbing. You can see it's rubbing on the glass here, which is obviously sharp on the edge. I've just managed to bend that bit of metalwork back about 1 millimetre just so it isn't touching it now. But that's another job. There we go. We all love restringing dial cord, don't we? Again, just a little update to the ongoing blog. I came in yesterday morning and found this dial pointer cord had snapped, so I'm going to have to replace it anyway. But I just want to film how it all goes round. I've got the instructions, so not too much of a problem, but yeah, the cord has been catching on the underside of the dial glass here, which really needs moving away about 1 millimetre or 2. I might put a bit of sellotape under that just to stop the sharp edges, just a tiny bit, and put some more at the back or something. But yeah, it's snapped. So yeah, the next time you see this, I'm going to restring it. It's not something I'm going to film because it's a flipping nightmare, I bet. And it'll give me the opportunity, where the cord goes around under there, it looks like it's a bit rusty or it's congealed grease. So I'll need to clean that out anyway, so I might as well replace the dial pointer string and the main tuning gang string as well. Right, I'm not sure how well this is going to film, but this is the back of the dial pointer with the felt pad, circular felt pad on, and the metal pointer, and it's in a bit of a cruciform shape, and I think the dial cord, if I can just pick up a little bit, goes through these brass tubes, and it's pinched on, and that's how it's set onto the dial pointer. Unfortunately, as you can see, someone's made an absolute bodge of this over the years. There's some like nylon crab fishing line there, this orange stuff, and then the point has actually been sewn onto the back, and one of these little brass tube things has actually broken off. You can see how it's meant to be crimped. So I'm going to have to find a way of trying to sort that out. Don't know how yet, but obviously the dial pointer needs to move for when you align the set. Yeah, but anyway, I've got the first dial pointer string, and I've reused a bit of the old string that was already on there. Someone had rotated this tuning drum. As you can see, the tuning gang's at maximum capacity there. Someone had rotated this tuning drum right away around from where it should be. That's how it should be. Ooh. Like this for the main tuning gang, with the slot pointed down here as I've got it there, and it works much more freely now. It doesn't pop off or anything, although that was the dial pointer to pop off. One other thing is a little bit of plastic had broken off this slot here, and it looks as if it's been broken off before, so I just need to super glue that on. But yeah, so I've got the, I don't know if you can probably see, I'm going to be pointing to the light, hang on, there we go. That's how it should go in at the back. And obviously the drum rotates on the shaft of the tuning gang here with these two screws to lock it in place. If you're ever going to restring a dial, once you've rotated it and got it, make sure you tighten these up, because once you start turning it, tension the spring, you'll probably turn it on the shaft before you notice and have to reset the whole lot again. So yeah, make sure those screws here are tightened up. Right, a little bit more on my sort of hourly blog, bit of fixing this. I've now repaired the dial string and set the tuning mechanism up, and it's all working nicely. I've put some modern, this is actually jewellery beading string. They sell it on Amazon for like several hundred yards, like 50p or something. I've also got all sorts in here. I've got this sort of fiberglass cord. I've got kite string, which is used. I've got some old bits and pieces that I've pulled from various radios. And this is the stuff. This stuff here. It's quite flexible but quite strong. I've tried to pull it. It's got about 40 or 50 pounds breaking strain. The other thing to use is Dacron. If you go into a fishing tackle shop and ask for some Dacron or braided line, that comes in various strengths, and people use it for sea fishing, which is big, far too big for this. But you can get 20 or 30 pound for like pike fishing and carp fishing. Some people use it for, and that's strong stuff. It really is strong, much stronger than this. But there's not a lot of tension here. It's only going round once, sort of once round, and then round these pulleys. There's no real hard sort of tension. But anyway, one job done. Where's the pointer? Right. So on the pointer, what I've done is I've actually used, which is quite handy, I actually used these lines on the corner of the manual, actually, because they're at 45 degrees. I just used those to line up the crucifix bit, and I've turned these tubes round so that's going to sit, if you like, on the dial glass. Oops, wrong way around. The string is going to come over the back, and I'll just pinch these two little sort of half circle slots. I'll pinch those together, and I've super glued these on. Let's see how it works, because what might happen is as soon as I start pinching it might break the super glue contact. and I won't be able to pinch the dial string on, which is, I'm going to have to take the dial glass off. That's going to sit up there somewhere in line with the top of the scale. Oops. So that's going to sit up there somewhere, and I'm going to have to pinch, if you like, I'm going to have to pinch these two clippy things on to the line either side like that, but obviously down there a bit behind here. So we'll see how that goes. If not, I'll come up with something else, some sort of wrap-around hook mechanism or something. And I might just see how that pad's been sewn on to the dial pointer. I reckon this dial pointer is absolutely wrecked. Let's have a look at it a bit closer. I notice. Flip it around, right. If you notice, this pointer should fit up that shaft there, and it's not. Someone's really broken this. But I have to make the best of a bad job. The only other thing I could do is make a new pointer completely out of brass wire, and just use a more traditional method of make an L shape and then with a little hooky thing in the end, and then wrap wire around that a couple of times and see how that goes. But it's nice to use the original pointer, but this is on the point of failing.